Hi, I thought today I'd do something a little different. Rather than the usual instructional videos on using Wappler itself, I thought I'd do something on relational database theory. This is primarily aimed at those who have either come from the design side or have little experience of server-side programming, so that they've got an insight into why we use a relational database model. So let's have a look. First of all, a little history lesson. Edgar Frank Ted Codd, who died in 2003, was one of the leading lights in the development of relational database model theory in the 1980s. And through that, he came up with what is referred to as Codd's 12 rules, although ironically there are 13, numbered 0 through to 12 in typical programmer fashion. He pioneered those databases, he defined the requirements, and what he did was he gave us a structure and conformity which all of our relational database models tend to follow, which allows us a bit of a common platform. These are jokingly referred to as Codd's 12 commandments. So what that means is it doesn't really matter which database system we use, MySQL, MariaDB, which is a variant of that, Microsoft SQL, Oracle, or whatever, the theory remains basically constant. So what is a relational database? There is a definition. It's defined as a database which has more than one table. Those tables have relationships to at least one other table. It has parent and child tables and has one-to-many relationships. And I'll just add, you can read the footnote there, a many-to-many relationship is effectively a bidirectional one-to-many relationship, so that is included within that definition. So each table will be a parent or a child, and can also be both a parent and child where 3 tables are involved, and we'll see an example of that later. So a parent will have 1 or more children. However, unlike real life, a child will generally only have 1 parent. So why not just have one big table? Enough of the theory, let's look at the practical examples and see why we use relational databases. Let's start with a fairly basic example. We have a table with 3 people in. These are 3 parents, John Smith, Jane Jones, and Walter Mitty. And each one of those has a child, in this case Sarah, Karen, and Paul. Codd's rules require that every record should have a unique identity. So what we have is a unique ID for each of them. We generally refer to that as a key field. And then we'll store the name of the child and the date of birth. And at that stage, that seems to work quite effectively. Unfortunately, or fortunately, whichever way you want to look at it, people tend not to stop at one child. So in this case, John Smith has also had a second child called Ken. So what we've had to do is amend the database structure and add a child 2 column in and a child 2 date of birth column. This makes a few problems. One is first the obvious one, wasted space here. And if we had hundreds, thousands, or even millions of records, that really is quite significant. Second one is if we think about searching, then we would have to say, if we were searching for Ken, does Ken exist in child or child 2 column? And also, of course, Codd's rules say that we should never have to change the database structure once it is set. So we've got a few problems already introduced into that. Add a third child. Now we've got Sarah, Ken, and Mary, who are children of John Smith. And now we have the problem of yet more wasted space. We have a search issue. Is now Mary contained in child or child 2 or child 3 to find that record? And of course we've had to amend that again. And that's not really a good situation to be in. What happens if somebody decides to have 10 or 12 children? The whole structure would start to fall apart. So our problems are each time the limit's reached, we've got to restructure the table. And bear in mind that a table with perhaps 1 million entries is not going to be a 5-minute job to restructure. It could take several hours or even days. We've got large amounts of unused space, and space is relatively cheap now, but databases are not a place to waste a lot of space. They work more efficiently if they're compact. We have searching problems. You say, is Mary contained in name or name 1 or name 2 or name 3? It's going to significantly slow down that search. And where we're talking millions of records, that really is a massive issue. So how do we get around to it? We introduce a relational model. Now what we've done, as you see, is we've split that original table into two tables. Here we have the first table with the 3 parents, each with their unique IDs, and in this case we're going to refer to that as their primary key, and each of those will link to a child table where we have a list of the children exactly the same. Each child has a unique ID. Okay, it could be a primary key, it could be referred to as a foreign key depending on how it links. Sorry, it won't be a foreign key. And then a parent ID, of course, links the parent and the child. So we can see John Smith links to Sarah, links to Ken and Mary, where Jane will only link to Karen and Walter will only link to Paul. What are the advantages of that? Well, first of all, we say the obvious one. We have no redundant space or wasted space. We'd see now we only have one column to search, so we don't have to search on child 1 or child 2 or child 3. And more importantly, when we come to add another one, we don't have to restructure. So now, Jane Jones in this case, has had a child called Kirsty. We can see her name and date of birth there. Kirsty has been allocated her own key field or unique ID, or as we'll see later, will also be a primary key. And that is linked now, parent ID to parent ID. So we know that Kirsty, child 6, born 27/9/18, is the child of Jane Jones. So you can see there we've just had to add one simple record, no wasted space, one quick insert, and then the relational model links them. What I've done here now is I've added an extra column, and I know officially we shouldn't do that because we're breaching COD's rules, but sometimes you do have to do some restructuring. And what we need to do now is to store the nationality of each child. So we've got John Smith as a child who is British, a child who is British, a child who is British. Jane Jones, however, she was living in Holland, had a child, Karen, who adopted Dutch nationality, and then moved to England. And when she had Kirsty, she decided that Kirsty would adopt a British nationality. The model still works. It still fits within the relational model as far as we've seen them. But has anybody spotted the drawback? The drawback is that we are now repeating this word British on a number of occasions. If we had 1 million records, we could have hundreds of thousands of copies that say British, hundreds of thousands that could say Bulgarian or Dutch, and that's going to be a massive waste of storage. We also have an issue regarding misspellings and misnomers. People could say British, some could say English, some could say UK citizen, or they may simply misspell it. So we need to try and add some conformity into it and reduce the amount of space that's used to store that. So how do we do that? Well, obviously the answer is a relational model. So you can see what I've done here is that I've introduced another table called nationality. Each nationality, in accordance with the rules, has its own unique ID, and those IDs are stored now in a reference field NID. So we can now see that John Smith, for instance, has a child Ken who is linked through to British. We can actually work backwards as well to say Dutch, all Dutch children. The only one we have is Karen, and the parent of Karen is Jane Jones. So that way we're storing a simple integer, which is quite a small amount of storage comparatively, rather than enough space for the longest entry within a nationality table. So that's how our relational database model works. I'm going to call it a day on that for the moment. We'll look at a practical implementation of that and how we, within Wappler and within a SQL Manager, can create those joins and join those tables to present a result. Few key terms for you to remember. Obviously, we're talking about databases. Each table would be perhaps child, parent, nationality, three separate tables. Each table has fields or columns. So, for example, parent ID, parent's name, first name, parent's second name. We have rows, that's the row across, so that would be all of the details relating to, shall we say, John Smith. Each must have a primary key, and where we have references, there will be a foreign key. We've talked briefly about joins, and I've highlighted how those joins would be made. And let's not forget the all-important SQL, structured query language, or standard query language, some prefer to call it, which is a language we use to query those databases. So what's next? I'll be doing an introduction to relational database theory part 2, and we'll be implementing the database model in MySQL and performing some basic queries in WAPLA. Hope to see you again soon. Thanks for viewing.